Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 1658, minimum operations to reduce x to 0. So basically at each time you can choose either the left and the right element and you're trying to make x exactly 0. And you're trying to choose, for example, the minimum number of deletions to reduce x to exactly 0. In this case, if you delete these two, then x becomes 0, so you return 2. And again, either point you can pop either the left or the right element, right? So really the choice is, do I pop the right or do I pop the left? And so let's just think about this. If we're trying to find the minimum, and why don't we just carve out instead like a subarray that when you get the total minus that subarray, it equals to x, right? So if you get the total sum, let's say this subarray, the total sum of the subarray, the total sum of nums minus this subarray is equal to x, then we just want to find the distance between the overall subarray minus this subarray, and trying to find the longest subarray that subtracting the whole nums minus this subarray sum is equal to x, right? Because that would give you a contiguous bit, basically splitting the array where the sum of everything that's not highlighted here would equal to x, right? And the minimum number of operations would be that. Not in this case, that would not be, it wouldn't look like this. In this case, it would just look like this, because if you remove this subarray that I'm highlighting, then the rest would equal to x, right? Okay, so let's do exactly that. So for iron range length nums, again, let's find a subarray sum. Let's go through all the subarrays and add nums of j. So if the total minus the subarray sum is equal to x, again, the total will just be the sum of nums. If that's the case, then we can just minimize answer with the length of nums, the whole thing, minus the chunk of that subarray gives you, that's how many elements you need to remove, right? So minus j minus I plus 1. And at the end, we can just return the answer, which is just going to be float of infinity. And again, if answer is equal to float of infinity, then return -1 because there is no result in that case. So yeah, let's run this. Submit it. And you'll see this is n squared, so it's a little bit too slow. So let me let it time out here. And okay, so even then, so the length of nums is the whole thing, and we're going to add nums of j. And again, if the total minus this is exactly x, then we need to minimize length of nums minus this subarray. Okay, so not sure why that's wrong. Okay, so if tot is equal to nums, then return the length of nums, because the whole thing needs to be removed, right? The whole thing is a contiguous chunk, right? In that case, the whole thing is summing up to, is equal to x, not nums, or whatever I put there. So submit it. And you'll see this times out. So let's go ahead and quickly try to optimize this, and I'll show you the way I came up with, which is basically to keep track of the subarray sums, so you get time limit exceeded, and then at each point, try to find the prefix sum, the sum of a subarray at the front, because you can, none of these are negative, right? So that makes our life easier. Basically, prefix sum of this subarray would be the prefix of this minus the prefix of this. So then let's find an element to the right as we scan our array that when the whole thing minus that chunk is equal to x, right? And we can do that using binary search. So let's accumulate this. And then again, we can just add nums of I, right? So we're just adding as we go. And then again, let's go ahead and go from the current to the end, because subarrays are always going from the current to the right. So while left is less than or equal to right, the mid would be the midpoint. So again, the value would just be p of mid. And if I is less than or equal to 0, then the low is 0. Otherwise, low is p of I minus 1, because again, the subarray of this is p this minus this. Okay, so again, if total minus, so the subarray sum is just going to be value minus low. So if this is equal to x, then we know we can minimize answer with length of nums minus the subarray size, which is just going to be mid minus I plus 1. And then we can also just find a better result, right? Otherwise, if to minus s is too big, then we move left up. Otherwise, move right down, right? Because these are all in order of the prefix sums. Okay, so minus ss. Okay, and at the end, again, if answer is equal to float of infinity, then just return -1. Otherwise, return the answer. So let's submit this. And there you go, passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.